Hello students, so this is the 18th lesson and we will talk about the last part of chapter 9, the Bayes theorem. So let's look at an example here. It is about a history test and also about the students who have done the revision. So R is that the student have done revision and H is the student who got passed for the history test. And you can see a table here. 40 students, there are 28 students have done revision and 12 haven't done the revision. And among 28 students who have done revision, 27 passed, and so on, so on. You can understand about this table. And then, so we can say that by using the tree diagram here, so 7/10 of students have done revision, and with those that have done revision, 27 out of 28 passed the test, and 3/10 haven't done revision, and 1/4 of them passed the test. So we have this is the given condition. Given R, probability of H is 27/28. Okay, given R prime, the result in H is 1/4. So what do we learn about Bayes theorem? First of all, we want to find this probability of revision out of history. So it is something that we done reversely, which means usually we will think about, those who have done revision or haven't done revision, then they have the test. But we want to attribute whether if they get passed, what is the percentage of the students that has done revision. So the meaning is something like this: who has passed test, and then we want to know the percentage of who have done the revision. So this is the meaning of it. So given that you passed the test and that the students has done the revision, so we can use the multiplication law, and then we can rewrite it for the probability of history. That means the test he has passed. That can be two groups of students. One group is that he has done revision, and another group is who haven't done the revision. And then we add them up, become the total number of students who have passed the test. And then we only want to find those who have done revision. So you use PR times PH given that R. So you can have this probability 9/10 by using this method to calculate the result. So this method we called Bayes theorem. So that means if there are a lot of mutually exclusive and exclusive events A1 to AN, so it can be 1, 2, it can be 2, 3, 4, so on and so on. I want to find out particularly if B happened. We know that B happened can be attributed to event A1, and then A1 need to B, A2 need to B, AN need to B. There are all the possibilities, the probability for B to be happened in the denominator. For the numerator, we only consider that AI that lead to B. So this is the probability of given that B AI. So let's see some example. So classwork 9.9, you can see that bag A that consists one red and one black ball, and then B 1 and 3, C 4 and 1. So a fair dice is thrown, and then the outcome is 1, 2, 3. Then we will draw it from bag A, 4 and 5, B, and then 6, C. Find the probability that a red ball is drawn. So you know, if you want to understand it, you can draw a tree diagram. So there's a 1/2, we got A, and then B and C, 1/6, 1/3, and then red and black. So this is 2/1, and then for this one, B for red and black, so it's 4/5, and then this one for C, red and blue, C is 4/5, sorry. Okay, so you have different probability for getting red from ABC. So part A is quite easy. You can just find that the probability, the required probit equals to 1/2 times 1/2 plus 1/3 times 1/4 plus 1/6 times 4/5. So the answer is 7/15. Okay, and then part B. Given that the ball drawn is not red, what's the probability that it is drawn from bag B? So given that it is not red, that means this is a black ball. And what is the probability that it is from bag B? So the required probability say not red is given that probability not red, and then it is come from B. It equals to that the probability of B and not red over the probability of not red, and probability of not red comes from all of them, so you're adding up all of them. A, B, C, and R prime. So you get this one adding up this probability of R prime. And then actually you can find it by using the result of A, which is denominator is 8/15 because 7/15 is red. The otherwise it would be 8 here. And for the numerator is 1/3 and not red times 3/4. So in this case, actually the result is 15/32. Okay, and then part C. Given that this is a red ball, what's the probability is from A or B? So the required probability equals to that result is A and R or C and R. And then the denominator is 7/15 from part A. So A and R is 1/4, C and R is 2/15, and then over this value. So it equals to 23/28. That's the answer. Okay, so another example here. So you can see that there are 4 brands of potato chips, and the ratio is this one. And then these are the percentage of potato chips that weight less than 50 grams. And then we found that there's a randomly found a potato chips is less than 50 grams. Found the probability that it is from brand 8. Okay, so it's pretty easy because you know that there are 4 cases. So 0.3, 0.2, 0.3, 0.2 become A, B, C, D. And then the result of weight less, okay, less than 50 grams. So they will be for brand A 0.5, and then 0.3, 0.2, and 0.1. So this is the result here. So part A, so the required probability, what would it be? So that means we given that this is less than 50 grams and it is from A. So the given condition is L, so we want to find the probability of L here, and the probability of A and L. So it is 0.3 times 0.5 for the numerator, and for the denominator you have to multiply all of them times 0.3 plus 0.3 times 0.2 plus 0.2 times 0.1, which means this one is A and L, B and L, C and L, D and L. And then the result is 15/29. And then that means you can, because your answer should be have 4 decimal place, so you have to divide it. So 0.5172. And then part B, the required for bit. So it is from part A, you know the denominator is 0.29, and then the B is 0.06, and then for D is 0.02. So it is 8 over 29. The result is 0.2759. Okay. Alright, so this is the homework for you, so you can finish it before next Monday. Okay, 30th of March. We'll see you next time.